3.2, number 44, says cosine x. Oh, this looks very familiar to something we just barely looked at no more than 5 minutes ago. Not exactly the same, but enough the same that I think you're good. Do you recognize what I'm talking about? We just barely looked at an example problem on that packet I gave you, where we factored out the sine x from the numerator. How's this one different? Factor out the cosine x from the numerator, which leaves us with sine squared x plus cosine squared x, because one of the cosines came out of that. And that entire thing equals 1. So that leaves us with cosine over sine, which equals cotangent.
There you go.
Beautiful. Do you see how that's just like the problem we just did? Really, honestly. Yes, perfect. Okay, and then 47. I will scoot the paper up as soon as I've written it down. Tangent x cosine x plus cosecant x sine squared x equals 2 sine x. Okay. Number 47. So start with the most complicated side first. I'm trying to see if there's something I can factor out, but I'm not seeing anything offhand. So I think the best move to do first would be to change everything to sines and cosines. Okay, so tangent would change to sine x over cosine x. And then that leaves this cosine x that it's multiplying, but because that one's now a fraction, I like to put that over 1. Then cosecant x is 1 over sine x. And then we still are left with sine squared x over 1. So if you it might not be a bad idea to get in the habit of explaining yourself. Like change tangent and cosecant to sine and cosine. So kind of like you're doing on that little packet, you might want to get in the habit of explaining what you're doing in each step so that you can remember and so that other people like me can follow it if we're grading it. Right?
And so for your benefit.
Sure. Okay, then let's go through and reduce these fractions. So reduce common factors is my next step here. Those cosines are common factors that we can reduce, because if we have it on the top and the bottom of the fraction, it equals 1. So it can go away. And then we also have 1 here that we can do the same thing with, correct? So that leaves us with sine x plus sine x, which, combining like terms, if you're adding them, it's 2 of them, so 2 sine x. If you're multiplying them together, then it's sine squared x. So hopefully you understand the difference between those. And that equals 2 sine x. The two sides. So what did we do on that step? Combine like terms. And we have a matching answer, right? We're good. Which one? 52? Okay. One minus sine squared beta, 1 plus sine squared beta equals 2 cosine squared beta minus cosine to the 4th power beta. Okay. All right. Both sides look pretty complicated. I would say the most obvious thing in my mind to work on is, again, the left side. What do you think it is that I'm seeing there? I think that multiplying those conjugates together would be a good idea. So foiling the problem, don't you think? Okay. So I'm going to FOIL. There's my little explanation, I guess. So 1 times 1 is 1. And 1 times sine squared is sine squared beta. And and then negative sine squared beta times 1 is negative sine squared beta. And then sine squared beta times sine squared beta is sine to the 4th beta. And then we can combine, it is negative, thank you. And then we can combine like terms. So 1 minus sine to the 4th beta. Now that I did that, I'm wondering if a different method would have been better. Does that ever happen to you? You start something one way, and then you see something else you maybe should have done first?
Well, if you do it, the 2 sine, like 1 minus sine squared beta, can you transfer that into like cosine, and that would have more equal.
Which means we should have done that at the beginning. That's what I'm thinking. So I'm just kind of, I didn't purposely mean to lead you down this path, but I guess it's a good illustration of if one thing doesn't work and you see that something would have been better, then don't be afraid to go back. So I've decided that's not good right now. Okay, so let's go back to this step and do what Cody was suggesting. And that is, what do we know about 1 minus sine squared beta? Yes. 1 minus sine squared beta is cosine squared beta. So since you guys have already worked on this, is there anything else you see that I should have done before I multiply this out? No. Yeah, I don't think you can do anything with that, not right now. So all I've done instead of foiling is I've done the Pythagorean identity.
You can transfer it to 1 minus cosine squared if you wanted to. But no.
Okay, well there's another thought. If we could use, okay, so the 1 would stay there, but then sine squared could be written as 1 minus cosine squared. I think that might be a good plan. I'm seeing that that could have potential. Does everyone see what I did there? Now, as I'm noticing that that might be a good plan on Cody's suggestion here, it's because I'm kind of keeping my goal in mind. So doing that actually gives me 1 plus 1, which is a 2. And it also makes it so that I've gotten rid of the sine, so that all I have is cosines, which my final answer is all cosines. So I really think that's a good move. Do you guys understand what I did there? It's another use of the Pythagorean identity. So both this and this are using the Pythagorean identity, correct? We're not going on to the next step yet. I'm just trying to make sure that you guys understand where this came from. So I need everybody with me. Does everyone understand where I got cosine squared beta and replaced that from 1 minus sine squared beta? Jordan, you get that? Are you sure?
Kind of.
Okay, that's what I thought. This is the Pythagorean identity. We have proved it. We know it's true. Therefore, we can move things around. We can say that sine squared is equal to 1 minus cosine squared. We can also say that cosine squared is equal to 1 minus sine squared. Right? So since this is true, these have to be true. Correct? Okay, so now let's look at what we did here. We took 1 minus sine squared and changed that to cosine squared because of this here. Because cosine squared is equal to 1 minus sine squared. So I replaced 1 minus sine squared with cosine squared. This one, sine squared is equal to 1 minus cosine squared. So we replaced that sine with 1 minus cosine. They both come from different forms of the same formula. Okay, are we okay now? Yes. Okay, so now what I'm going to do is combine these terms here. So I'm just going to rewrite this. Cosine squared beta, and then I'm going to combine the ones. So that I'll have 2 minus cosine squared beta. 1 plus 1 is 2, and then it's minus cosine squared. Okay, now I'm going to distribute. So this was combined terms. And now I'm going to distribute. So distribute. Cosine squared beta times 2 is 2 cosine squared beta. And then cosine squared beta times negative cosine squared beta is negative cosine to the 4th beta, which matches exactly what we were trying to match. Thank you, Cody, for your help. That was awesome.